Welcome back. In this video, I would like to add some extra elements to make the code from the previous video a bit more interesting. Today I will try to demonstrate how Tranter's code is not only great for setup, but can also be used as a template to try some simple waveform synthesis. On a related note, although one of my goals is to try and build some synthesizer-like programs, given the many alternatives, it seems important to ask whether ALSA is useful for accomplishing this goal. I think the answer is yes. Realizing there may be many potentially better, maybe easier options, the ones I have looked at all seem to require more setup and dependencies. Although the code may be more complex for ALSA, it seems like there are fewer additional dependencies overall, and also more options. Especially since it runs on most Linux systems. Examining the homepage indicates that ALSA is capable of basically everything necessary for a synthesizer, it even does MIDI. There are also many useful resources for building synthesizers in ALSA. We talked about Tranter's article last time, which is a great resource for getting set up and running. ALSA Programming How to by Modifies Nagorni is another helpful resource. It makes a great supplement to Tranter's article, especially because of its synth-centric focus, and the fact that it contains the code for the SAW waveform that we will be working with today. I did run into some issues with Nagorni's code though, especially with buffer settings, and I do plan to talk briefly about those later on. In terms of projects, there's phasex, which I also mentioned last time. Since all of the source code is available, I think it will be a great resource for later videos in this series. Nagorni actually created a project called ALSA Modular Synth. Unfortunately, I don't think the source code is available for this one though. I saw the audio programming book mentioned on a forum by the creator of Mutable Instruments, and this is a really great book, especially the first half. I am sure there are other resources out there too, and I hope to find and discuss them in later videos. Next, I would like to talk about the code for this video, sawplayer.c, and I would like to begin by discussing the background. I already introduced Nagorni's article in the resources section a minute ago, but I would like to talk a bit more about it. According to Nagorni, the article is meant to provide a brief introduction to writing simple audio applications with ALSA. While the whole article is very informative, the section that was most helpful for sawplayer.c was section 2 Basic PCM Audio. Nagorni says, if you remove the explaining text, you end up with a minimal PCM playback program. That is sort of true, but for me there were a few caveats, and I actually needed to combine parts of it with the Tranter code to get it to run on my system. Examining the code itself, which I have on GitHub here, the setup steps essentially come directly from Tranter's code. I've added some extra comments, mainly based on the additional synth-centric explanations by Nagorni. I have also tried to describe the ways that Tranter's code and Nagorni's code are doing similar things, and which parts of which code are related to the other and how. Next, in terms of audio routing, I left the original Tranter code, commented out, and tried using the Nagorni method, just because I liked Nagorni's use of variables, and wanted to see if I could get it to work. I did use plug HW00 this time instead of default, and, as I mentioned last time, it may be necessary to change this depending on the system and setup. The other thing that I wanted to mention is the really interesting way that ALSA does error handling. Assigning the code to int_rc, and then checking like this is really great. Next, I would like to talk a bit about send PCM HW set format and associated considerations. With ALSA, you have a ton of freedom to change audio format, but since all of the format-related settings are dependent on each other, if you change one, you'll likely have to change the rest to match. On another related note, if you have audio recorded in a certain format and you want to use the simple code we have been looking at to try and play it back, it is completely doable with the Tranter example from the last video, if you input your audio file instead of /dev/u random. But, if a format different than the format of the audio file itself is specified in the code, you will end up with some really interesting distortion. It might sound like the chipmunks. It might sound very slow, or it might also sound like terrible noise. But it will probably distort in some way, which can be used to interesting effect, but is something to be aware of. Another thing that I really wanted to cover was the setup of audio buffers. Nagorni and Tranter use slightly different methods, and, while the Tranter method works great for me, I was completely unable to get the Nagorni method to work. I did leave the Nagorni code commented out in sawplayer.c, along with some brief discussion of the issues I encountered, for reference though. Next, I'd like to talk about the best part of the Nagorni code, the simple stereo saw waveform. This code is pulled directly from the Nagorni article. It works really great, and it's really fun to have stereo, as a majority of the synths I have worked with are mono. I will demo it in a minute, but I just wanted to point out that, due to my audio routing method, and the compression of the finished video on YouTube, it may not sound as great, or stereo, as it does on my system. So, like last time, the code doesn't loop. It just plays one time through and stops. I am using send PCM drain, so it will play out the remaining frames, and then stop. At this point I would like to compile and run the code. The syntax for the compile command is essentially the same as last time. gcc sawplayer.c-o sawplayer -la sound to link ALSA. Next, let's run it. Great, so we were able to compile it and run it with no issues, and we have a fun example of a very simple method to play a stereo saw wave. This method could also be used with other simple waveforms, and this code could function as a template for testing waveforms independent of a more complex synth-like program. While this is more interesting than the white noise example, I realize that we still need to add quite a few elements. For example, it would be nice to interact with the waveform in various ways, and that is something I plan to start looking at in the next video. Thank you for watching.